welcome back. We are going to do the back here, and those three are word problems. So we want to make sure that we're using our notes, and this could be different depending on which class you're in, but definitely we've got like an eagle problem, an airplane, and a flagpole problem that in our notes. And again, before the test, make sure you fill in one more of these. You could fill it in with one of these or another one from your packet. Make sure you have a fourth one filled in. Okay. So I'm going to use this to help me. This is an airplane problem, so I can probably use this to help me. I'm just going to draw a picture and lay out the information. So it says the airplane over the Pacific. So here's my airplane. I'm going to call that A. Sights an atoll at an angle of depression. So the airplane is looking down at 5 degrees. And so that means whoever's down there is looking up at 5 degrees. It's kind of weird, okay? At this time, the horizontal distance from the airplane, the horizontal distance from the airplane to the atoll is 4629. So because they use this word horizontal, I put it there as opposed to the distance between the airplane and the atoll. Okay, so I guess I'm just going to call the atoll T. Now it says, what is the height of the plane? So we know height is here. So we're going to call that X, and there we go. Now it's just the plain old steps. Since I'm solving for the missing side, I'm back to using this, because this is what helps me solve for the missing side. Now, my airplane example, we were solving for a missing angle. So just because it's an airplane problem doesn't mean it's going to be a missing angle or a missing side problem. Okay, so here's my reference angle. I'm going to label this opposite and this adjacent. So the best pick here would be the tangent. So the tangent of 5 degrees is opposite over adjacent. And so I'm going to multiply both sides. This is a one-step algebra problem. 4629, and that cancels. So here we see x is equal to 4629 times the tangent of 5 has to be equal to x. And they said round to the nearest meter. Cool. So let's do that. 4629 times the tangent of 5 equals 404.9. They said round to the nearest meter, so I'm going to round to 4. Whoop, that doesn't look like a 4. 405 meters. Now, since we're getting ready for the test, we're going to plug this back in. So it looks like if that is a really little angle, and this is 405, that's a number that makes sense, because that's a really small number. This number up here would be a really big number, so it makes sense that this number would be quite a bit bigger than that number. Okay, next question. A spotlight. Interesting. So my spotlight is mounted on the wall, so this is my light, and it's mounted on the wall 7.4 foot above the security desk. So up or above would probably mean 7.4 goes there. Okay. Then it's used to light an entrance door that's 9.3 feet away from the desk. So it sounds like here's my desk and here's my entrance door, and it's 9.3 feet away between the desk and the entrance door. This is my desk. Okay. So here's my spotlight above the desk and the entrance door, and so the light is shining down at the bottom of the entrance door. To what degree is the angle of the... So they want to know this, theta. Well, it makes a z, same here. If that was 5, that's 5. So this is the angle they want, that angle right there. We can call it angle E, or again, it sounds like we're solving for a missing angle. So the Greeks love to call that theta. So now I just have to pick which would be the best trig theorem. So we've got to label our sides. This would be opposite. This is adjacent. Nothing's happening here on the hypotenuse. So that means that the tangent function, so the tangent of theta, would be 7.4, opposite over adjacent 9.3. And so theta would be equal to the inverse tangent. So this is like our homework last night. So we just got to do that. Now, not sure, again, check inside here. The back of this was when we used tangent, and this looks really familiar. See how we had numbers on the two sides, no information on the hypotenuse, so we used inverse tangent to solve for the missing angle. And this question's just like those. So let's do it. Let's type this in, 7.4 divided by 9.3, enter. And then second tangent, there it is. And it said round to the nearest degree. So instead of 38 point something, we're going to round to the nearest degree. That looks like 39 degrees. Now, since it's a test, we want to make sure that makes sense. So if we plugged this back in, 39 degrees, I think that makes sense. 39 degrees for an angle. Okay. Last one. Triangle. Find the angle of elevation of the sun from the ground. So it looks like we're solving for an angle, and so I can call that theta. So the angle off the ground to the top of a tree, so this is the top of the tree and this is the bottom of the tree. Find the angle of elevation of the sun when a tree that is 10 yards tall. Okay, so this would probably be 10 yards since that's how tall the tree is. Cast a shadow. So our shadows live on the ground. So here's my shadow. Cast the shadow that's 14 yards long. Okay. Round to the nearest degree. So once again, here is my angle of elevation, elevated off the ground. And I'm going to label my sides in relation to my reference angle. So this looks like opposite, this looks like adjacent. Nothing's happening here at hypotenuse, so it's probably quickest to pick the tangent function. The tangent of theta is opposite over adjacent. Awesome. So this one's just like the last problem. Theta would be the inverse tangent of 10 over 14. Let's type that in. Clear. 10 over 14, enter. Inverse tangent, I'm told to round to the nearest degree. So I'm going to round that to 36 degrees and just double check that the answer makes sense. So when I go back in here, if that's 36 degrees, that looks like that makes sense. Thanks for joining us. Good luck on the test.